Hello guys, my name is Naveed and welcome to our YouTube channel. Today we are going to solve a machine learning application in healthcare, like how you can use artificial intelligence in healthcare application. So our problem is breast cancer detection system. So if you didn't subscribe my channel, hit the bell icon. Let's so you can just get the you can say notification whenever I upload the new video, new project related to artificial intelligence, machine learning. So you just get the notification. So let's start to the application. So same as previous, working we will work with collab.research.google.com. Come to this website, then simply connect, and then rename our file with the simple cancer detection system. Enter. And we have uploaded this data.csv file, and this csv file is available in a github repo in the description. So this code, this dataset is available in github repo, so you don't need to worry about that. So first we will import some basic you can say libraries, then we will load the dataset, perform some eda, perform some statistical analysis, correlation testing, then we will train the model. So main purpose of this video just to tell the students like how you can use machine learning in healthcare. So this is the just you can say give them the idea how you can use machine learning in healthcare. So let's first import some libraries. So load libraries. So first of all we import basic library numpy as np, then import pandas as pd. Then we for visualization we will import some libraries. So from matplotlib dot pyplot as plt, and percentage matplotlib dot inline, so just to showcase the graph in Jupyter notebook. And to make the subplots, simply we use the grid. So import matplotlib dot grid spec as grid spec, and seaborn library as sns. Then we will import some libraries for performing machine learning, splitting our data set. Then uh, the model, random forest classifier, sport vector machine. So import ml libraries. So from sk learn dot model selection, import train test split, and then from sklearn dot ensemble, import random forest classifier, and from sklearn import svm, and for evaluation matrix simply from sk learn import matrix. From matplotlib simply change from to import no module matplotlib. Okay, now we have successfully import the libraries. Now we will load the dataset into our data frame. So load data, make it heading, shift enter. So in pandas data frame pd dot read underscore csv, and the name of our data file data.csv, Yes, data.csv, and first row is a header. Let's see first 5 rows. So okay, so this is our datasets ID diagnosis. So this is the variable that we are going to predict, our y variable, and yeah, this is our dataset. So I think we can remove this column unnamed 32 ID. So let's remove you can say these columns. So let's perform some EDA. So we will drop this column. So df dot drop id x is equal to 1 and in place is equal to true. And we are also going to drop, you can say, last column unnamed 32. And let's see the size of our data frame. Length of df 569. Okay, now we will see how much, you can say, different diagnosis we have. So we from this way we can know how much value you need to predict. Either you need to predict to binary classifier. Which classifier do you need? So first of all, we need to get the unique values from this y variable diagnosis. So df dot data frame dot column name dot unique. Okay, so we have only two values, so M and B, malignant, and like two where patient, the one who have cancer, second don't have cancer. So now we can also map these values to 1 and 0. So we can convert our data set from categorical into numerical. So df diagnosis is equal to df diagnosis, and then we can map M to 1 and B to 0. df dot head. So yes, we have successfully we converted our categorical data into numerical. So now let's see some statistics of our data. So from data frame df dot describe, so it will perform many things for us. Let's see df dot describe. So it okay says the count, mean, standard deviation, minimum percentile, maximum value. So just from this word. Okay, next we will plot our y variable like this diagnosis. So we are going to split our data frame into two based on the diagnosis column value. So FEATURE feature underscore mean, and first we will select any random some columns. Then first we perform analysis on this column, then if we need we can include more columns. So this is the process, and as I explained before, this is just a demo to show the students how you can use machine learning, how you can solve machine learning problem. So we will first make a list of df dot columns 1 to 11, and then we will split our, you can say, data frame into two. dfm is equal to df diagnosis is equal to 1, home dfb 0. Okay, now let's get the frequency of cancer stages. So sns dot count plot df diagnosis and label is equal to count. Sorry, label. Okay. From this graph, we can see that there is a more number of benign stage of cancer which can be cured. So let's do that analysis with little feature selection. So we will draw some correlation matrix. So uh, n- why we are going to draw some correlation matrix? So because correlation graph is that we can remove multicollinearity. It means the column that are depending on each other, so we should avoid it, because what is the use of using same column twice? So let's check the correlation between feature. Now we will do this analysis only for feature mean, like the features that we randomly select, and then we will do for others. We'll see who is doing best. So let's correlation is equal to df feature mean dot correlation, and then simply we need to plot this figure. Provide the figure size is equal to 14 by 4, and let's plot the heat map. sns dot heat map correlation c bar is equal to true, square is equal to true, annotation is equal to true, fmt is equal to 0.2f, annotate kws is equal to size 15, x tick labels is equal to feature mean, y tick labels is equal to feature mean, and c map is equal to cool warm. So feature mean is not defined. Okay, s is missing here. Okay, so from this graph, we are getting these different things. We can conclude different things. For example, number one is the radius parameter and area are highly correlated as expected from their relation. So we will use any one of them. Second is compactness mean, concavity mean, and concave point mean are highly correlated. So we'll use compactness mean from here, and the selected parameter we use is perimeter mean, texture mean, compactness mean, and symmetry mean. So the prediction variable that we will use, prediction variable is equal to texture underscore mean perimeter mean smoothness mean compactness underscore mean and symmetry mean. So these are the variable that we will use for the prediction. Now we are going to split our data. So simply split our data, the 30/70. So train test is equal to train underscore test underscore split data frame, and test underscore size is 0.3. Print train dot shape and print test dot shape, shift enter. And so this is our training and testing data. So now we just going to, you can say, taking the training data input using the prediction variable that we selected from our correlation analysis. So train underscore x is equal to train prediction underscore variable train underscore y is equal to, and so train underscore y is equal to train dot diagnosis column. Same we do for test. So test underscore x is equal to test and prediction variable, and test underscore y is equal to test dot diagnosis. Okay, so now the purpose of this lecture just to showcase the use case of machine learning for student in healthcare. So simply we will use the two classifiers, random forest classifier and sport vector machine. So simply first make the model is equal to random forest classifier, and the estimator that we are going to make, that would be mators. Let's make it 100. Then let's fit this model on train underscore x and train underscore y, and let's make the prediction. First simply run this training. Okay, then make the prediction is equal to model dot predict on test underscore x. Okay, so now we use the accuracy matrix. So matrix dot accuracy underscore score prediction comma test underscore y. So we got the 94% accuracy for the random forest classifier. So now we are going to use the sport vector machine. So model is equal to svm, then model dot fit on train underscore x and train underscore y, then prediction is equal to model dot predict test underscore x, and then that is svm dot svc. Okay, then same we are going to measure the accuracy score. So we got the 90% accuracy for sport vector machine. So SVM is only giving us, you can say, 90% accuracy. Random forest give us 94% accuracy. So there are different methods, different techniques that we can use to improve the model accuracy. But again, I am saying the purpose of this video just to tell the student how they can use machine learning algorithm for the healthcare, for the betterment of humanity. So that's it for today. If you like my video, click on subscribe button, hit the bell icon, and let's make another video. Bye bye.